So let's define mathematical framework for how to deal with this. We define skew of K as simply the number of G minus number of C in the first K nucleotides of the genome. And skew diagram is simply a plot showing skew of K against K. Now let's construct skew diagram for the E. coli genome. It looks beautifully. Where do you think is the origin of replication in E. coli? Something that we almost had no hope to find. Of course, it's at the point where it was decreasing and then suddenly start increasing, which is here. We found the replication origin in E. coli. And now, let's try to find frequent word in this origin, and hopefully we will find DNA A box in this way. Well, after we run our frequent words problem, unfortunately, it turns out there are no frequent words that appear even 3 times in this replication origin, which means that we failed. There are many reasons why we may fail. Maybe origin of replication as derived from skew diagram doesn't show precisely to the area where we want to see. Or maybe, just maybe, we don't have a good grip on how hidden messages in E. coli origin look like. Should we give up? Let's try to proceed further and figure out what else can be done. And when we were looking for frequent words, our view of frequent words was very naive. We assumed that frequent words are simply K-mer. But maybe hidden messages that cell uses to initiate replications are more elusive, more subtle. Let's look at this origin of replication in Vibrio cholerae and try to see. Maybe there is something else. We already found 6 9-mer in this region, but maybe, just maybe, there is something else that deserves our attention. And if you look carefully there, then you will see that in addition to these 6 hidden messages, there are 2 more. There are actually 2 9-mers that look almost like canonical 9-mers. They differ just in a single mutation. And they also represent DNA boxes because DNA can bind not only to the perfect 9-mer, but to different variations of this 9-mer. So to find this type of more elusive frequent words, we need to solve frequent words with mismatches problem, when the input is a string text and integers K and D. We want to find all most frequent K-mers with at most D mismatches in the text. And finally, after we've done this and run our frequent word with mismatches problem, we do find somewhat more elusive frequent words in E. coli genome. And they turn out to be, indeed, real DNA boxes in E. coli. Now, what I described is a very idealistic view of how replication can be found. In reality, some bacteria have fewer DNA boxes, and our frequent words algorithm won't work for finding them. Terminus of replication is often not located directly opposite to the origin of replication. And the skew diagram is often more complex than in the case of E. coli.